Hello, Assalamualaikum. My name is Syamil Bakri bin Ibrahim. My metric card is CE190170. So today I would like to explain for this part 3. So my part is I'm going to do for 3.1. So the 3.1 require me to do tabulate the desired parameters. So this is the block diagram that I already draw in the Simulink here. As you can see there. As you can see this block diagram that I already draw from the lecture that gave us to draw the circuit. Okay, so I already put in the table for VA is 1. For VA is 1 here. Okay, so the EMF constant KB is 0.1 and the disturbance amplitude at the pulse generator is 0.4. So when I double click, it already shows the amplitude is 0.4 for the pulse generator on disturbance amplitude. So yeah, okay, so I'm going to continue for the words transfer function that we use in feedback control and contain C S equal K per S to enforce 0 steady state error where K is determined as 0, 5, 10 and 15 in this experiment. From this identification, we can compare the simulation with the theoretical result is similar as the waveform becomes more stable as the number of gain. So yeah, so that's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizwan Shakir bin Muhammad Hamzani. My matrix number is CA190085. So for this assignment, for this experiment, I have to, for my part, is question part 3.2. So these are the block diagram that I got for part 3.2. So we have load, transfer function here, load, and then scope and all, just like a previous one. So just upgrade to for this part lah, for this part. So first we need to run, and then we open scope for graph. So these are the output for part 3.2. This is the graph that I got. For this is C max, C final, and then next one is the value for overshoot. So there is a manual calculation for C max and C final. So this is how you calculate for manual. C max minus C final times over C final times 100%. So this in the table is from simulation or result simulation. So yeah, I think that's all from me. Thank you. Assalamualaikum.
Assalamualaikum and hi. My name is Nuraini Nadira binti Kamal Arifin. So for this lab 2, speed control using Simulink, I will show the simulation for part 3, question 3.3. So this is our block diagram. And this is the K over S value. The K value is 0. Let me run the simulation. The output will be like this. There is a steady state error here, steady state, and this overshoot. This is the overshoot. It's the time settling time. So next is for the K equal to 5. You can see that there is a curve over here and the overshoot here. And K equal to 10, it is becomes curve because when we add another transfer function and the value is equal to 10, and as value remain. So the benefit for this transfer function is it's eliminate and reduce the drop value for the speed control. And before that, before we move to k equal 15, explain that k equal 5 is it eliminate and reduce the drop value for the speed control tool. It promotes the speed become more efficient. So for k equal 15, it starts to reduce the drop value and becomes curve, which is here. The speed increase based on this graph when adding the CS equal to 15. 15 is at K. Then we can see that the maximum overshoot between these three are different. As for K equal 5, there is no overshoot or it is invalid. Then for K equal to 10, there is overshoot 1,999.89%. K equal 15, the overshoot is 304.87%. Hence, the K equal 10 and K equal 15 is the same response condition, but different value at the maximum overshoot on the early stage. At the end of the constant value becomes 1 because of the VA set at 1 value, which is here. So for the steady state error for K equal 0 is 2.2, K equal 5 is 1.56, K equal 10 is 1.2, then K and last is K equal 15, 8.65 for the steady state error. So that's all from me. Thank you.
Hi, my name is Chong Shin Lin, matrix number CE190008. So for this lab part number 3, I'm going to explain 3.4, discuss and compare the result obtained using two control method, which is feed forward and feedback control. So as you can see here, this is the feed forward block diagram that we have done from the previous lab. This is the block diagram, and then this is the output graph from the feedforward block diagram. And then next one is, this one is the feedback control, and then with their output. So from these two output here, we can see that there is difference between these two. So from this both of the output, we can know that feed-forward control system, and it is a system which pass the signal to some external node and reject the disturbance before they affect the control variable. Then for the feedback control system, is basically a control system where the output depend the generate feedback signal. Based on the feed forward and feedback control system, we can conclude that feed forward control system is used to reduce the effect of measurable disturbance, while the feedback system is to trim and compensate for inaccuracy in the process model, measurement error, and unmeasured disturbance. From this experiment, we can see that both feed-forward and feedback control system has the same purpose, which is to improve the normal circuit. For example, for DC motor to reach its desired output. So that's all from my part. Thank you.